Now we do have a program which should easily demonstrate the declaration of a pointer variable, initialization of a variable, and then to print the results onto your screen, which makes use of pointers. Now if you look at this program, this address of A is the value of A PTR. Then if you closely have a look at this, these star and ampersand are inverses of each other in this program. This is what has been demonstrated in this entire program. And the next section introduces you towards calling a function by reference. What is there as calling a function by reference? Right at the time of functions, we came to know that there are two different methods to call a function. One out of those happen to be calling a function by value, and the next one happen to be calling a function by reference. So how do we have call by reference done? Call by reference is done with the use of pointed arguments. How do I do it? You pass address of argument using an ampersand operator. It allows you to change the actual location in memory. Arrays are not passed with ampersand because the array name is already a pointer. As we had a discussion on strings yesterday, we told that every string behaves like a pointer. It points to the address of the first character in the string. Likewise, arrays are not passed with ampersand operators because the array name by itself is already a pointer. Then what do we make use? We make use of a star operator or an asterisk operator. It is used as an alias or a nickname for a variable inside the function. Let us have a simple example as how to have a call by reference done in a function. Imagine I have a function called void double, which takes in as parameter an integer pointer by the name number. Now this number, that is the value in number, is equal to 2 into the value that is present inside the place number or inside the address that is being contained in the pointer called number. Now here asterisk number is used as a nickname for the entire value passed. So if you look at this function, this acts like a normal function protocol wherein we initialize a variable, we call a function, and then we do define a function. So this is a typical example of a queue by reference where a star NPTR is used and star NPTR is a number. Now moving on towards how to use a constant qualifier with pointers. We all know that const, that is the keyword const, is used for constants. How can I make use of this constant qualifier? Because the variable cannot be changed. Whenever I make use of a constant qualifier, the variable's value cannot be changed. It could have been a good idea to have a constant if the function does not need to change a particular variable. Attempting to change a constant happens to become a compiler error. So take care while trying to modify the value of a constant. I repeat again, a constant qualifier is a 1 which can make a variable not disturbed. That is, you cannot change the value of a variable once it has been declared as a constant. It would be a good idea to have a constant if the function does not need to change a particular variable. Attempting to change a constant variable will lead to a compiler error. How about pointers? Constant pointers point to same memory location. It must be initialized when declared. That is, for example, if I am going to make use of a constant pointer, please make sure it is initialized right at the step of its declaration itself. That is, fix a value for that pointer variable right at the time of declaration. So int const myptr happens to be ampersand of x, which means that the address of x is assigned towards myptr, which is a constant. Then a constant myptr equals ampersand x is also a regular pointer towards a constant integer. Then a const int star const ptr, which is equalated towards an address of x, can be termed as a constant pointer to a constant int. X can be changed, but the PTR cannot be changed. That is, the value can be changed at the level of x, but it cannot be changed in terms of your pointers. This is how we do make use of constant qualifiers within pointers. We can have a lot of examples that work with pointer arithmetic. So, it is important to know what a pointer arithmetic is. Imagine there are 5 elements in an integer array on a machine with 4 bytes for ints. Imagine this is a machine that has 4 bytes for every integer. And imagine there is a pointer by the name VPTR that points to the first element of the given array by the name V. That is, VPTR points to V of 0. Imagine V of 0 starts at a location 3000. So, the first element would be at 3000 to 3003, the second element would be from 3004 to 3007, the third from 3008 to 3012, and so on. VPTR always points to the first element that is present inside the array V. At location 3000, VPTR will be equivalent to 3000. Whenever I say VPTR plus equals 2, that is whenever I try to make use of a shorthand operator plus equals, what has happened? It sets VPTR to 3008 rather than 3002. What do I mean by this here? This is not a normal arithmetic which adds 2 towards 3000, rather adds 2 different integers and their spaces along with the initial point. That is, it adds 8 bytes towards the address of the first variable, that is V of 0, which happens to be 3008. And then VPTR points to V of 2 because this is a machine that has 4 bytes for integers. So, whenever I say VPTR equals V of 0 and then say VPTR plus equals 2, please make a note, it is going to point towards V of 2 rather than 3002. Now, we shall look at a few more pointer expressions and pointer arithmetics. Before this, we had an example where the arithmetic tried to add a value towards your pointer. How do subtractions happen? It returns the number of elements from one to the other. That is, whenever I say VPTR equals V of 2 and I say VPTR equals V of 0, then VPTR 2 minus VPTR will be equivalent to 2. I explain it in detail. Imagine VPTR 2, this is the pointer variable, VPTR 2 equals V2 is my initialization. Then I try to claim that VPTR equals V of 0, that is VPTR 2 points to the starting address of the second element in your array called V. This VPTR points to the very beginning of your entire array, and when I say VPTR 2 minus VPTR, it does not return you some value like 3008 minus 3000, which is 8. Instead, it says that it is equivalent to 2. That is, there are 2 elements between this and this. Then you can also have pointer comparison in sense of a less than symbol, a equals check or a greater than check. How is this possible? See which pointer points to the higher numbered array element. Also see if a pointer points to 0. Pointers of the same type can be assigned to each other. If the types are not the same, a cast operator must be used. What is an exception? A pointer to void can be an exception here. That is, usually we make use of void for a null return type. So, whenever you want to have a pointer towards that, make sure the generic pointer represents any particular type. No casting is needed to convert a pointer to a void pointer. Void pointers cannot be dereferenced. So, these are the important points that we have to take care whenever we are worried about the pointer arithmetic. Then, what is the relationship between pointers and arrays? Arrays and pointers are very closely related. An array name is like a constant pointer. Pointers can do array subscripting operations. We know that an array is a subscripted variable. Why do we call an array as a subscripted variable? Because it gets designated by its different indices it comprises within itself. Any element within an array can be referred with its particular index. Now, let us try to declare an array which is B which has 5 elements onto it, and let us have a pointer assigned towards this array. An array name actually is the address of the first element, or the pointer always points to the address of the first element in an array. You can explicitly assign that pointer to the address of the first element. What I try to say here is, I have an array which is B, that is, it comprises of 5 or 6 different elements within it. Now, I would like to assign a pointer towards this array. How can I have that done? I can simply say that bptr equals B, which means that I can straight away make use of this array name to initialize this particular pointer. Then, what does this actually do? This stores the address of the first element in the array B as the value in bptr. If you would not want to do this in this way, I can straight away go out and say that bptr equals the address of the first element present in B. Both these would do the same thing, that is, this stores the address of the first element in the bptr. Here I have explicitly done the assignment of the address of the first element into bptr. So, in this way, an array is very closely related with a pointer. Then an element n inside the array B can be easily accessed by having a simple operation. Imagine I have n elements in an array called B, that is, this array B consists of n elements. How can I straight away access the nth element? It can be accessed by a simple notation, what calls as star, which means the value of bptr, because we know that bptr is a pointer that points to this particular array, and you can straight away say that it is n. So, this would straight away access the nth element in your array by the name B. Now, what is n over here? N here is termed as the offset, or it is a pointer notation. An array itself can use pointer arithmetic, that is, an array B of size 3 is same as that of what I call as B plus 3. Pointers can be subscripted, that is, bptr of 3 is an array subscription which is the same as that of B of 3. That is why we normally tell that arrays and strings are pointers by themselves, where they point to the address of the first element contained in them. Arrays can contain pointers, that is, an array can be an array of strings. String points to the first character in the character array. Each element of the suit is a pointer towards a particular character. Strings are not actually an array, these are only pointers to string in an array. The size has a major role over here. Here the suit array has a fixed size, but strings can be of any particular size. Now, we can have very many examples that could easily demonstrate the relationship between an array and a pointer as like this. Then we move on towards pointers to functions. As we mentioned earlier, pointers can be used in functions in terms of call by reference. In what other ways can it be made use? A pointer to a function contains the address of a function. Similar to how an array name is address of the first element, you can have function name is the starting address of the code that defines the particular function. we have had it here. Whenever I said I have an array and I have a pointer towards this one, it points to the address of the starting element. Whenever a pointer is applied to a function, it means that the function name is the starting address of a code that defines that particular code. Then how could you have function pointers? Function pointers can be passed to functions, it can be stored in arrays, it can be assigned to other different function pointers. I come again. Function pointers can be either passed to functions, they can be stored in arrays, or they can be assigned to function pointers. Then we can have a simple example like a bubble sort, where we can make use of a function pointer. A function bubble takes a function pointer. Bubble calls this helper function. This determines ascending or descending order sorting. The argument in the example bubble sort that we have in our hand is a pointer towards the function. Now when I say the return type bool along with a pointer compare int comma int, it tells that bubble sort has to expect a pointer to a function that takes 2 ints and returns a particular bool. If the parentheses were left out in this example, it would look something like boolean, then a pointer to this function along with 2 parameters which are of type integer and integer. It declares a function that receives 2 integers and returns a pointer towards a boolean. So a small brace here and there could make a vast difference. These are the different aspects of a pointer that we have to note in C programming.